What we're going to talk about now is a quick overview of some of the short-circuiting aggregate operations that occur in Java streams. We'll talk in a lot more detail about some of the non-short-circuiting or the run-to-completion operations, but I want to focus on these real quick because they're a little bit different, and it's interesting to understand how they work and what the behaviors are. So we'll talk about short-circuiting. So you don't go through the entire sequence. You take a shortcut, or you get there faster, if you will. Recall that aggregate operations may process all elements in a stream. So map, for example, processes all elements in its input stream, unless, of course, an exception is thrown. If the behavior throws an exception, then obviously it'll stop if that exception is not caught and handled in the context of the behavior. But we're going to ignore that particular use case for this discussion. In contrast, short-circuit operations intentionally halt further processing after a condition is no longer satisfied or is satisfied, depending on what you're doing. And that does not require throwing exceptions. So you can short-circuit stuff without exception handling, exception throwing. So here are a couple examples of short-circuiting operations, which we'll talk about and look at in more detail later. One is takeWhile. So this is a short-circuit intermediate operation that returns a stream that consists of a subset of elements taken from this stream that match a given predicate. So takeWhile takes a predicate, and what it'll do is, as long as that predicate is true, then the elements will be emitted from the stream. As soon as the predicate is no longer true based on what's in the stream, then the stream is ended at that point. There's no more further emissions of values. Another method that limits stuff and short circuits is limit. So it's a short circuit intermediate operation that causes the stream to operate on a reduced size. Here you can imagine having some kind of stream where we're going to take some data, we're going to take it while it matches a predicate, but we only want to take up to max size number of elements, let's say 5, and let's say we have thousands of elements. So limit says once the limit is reached, then the stream stops emitting and we will continue on to other operations, but no more emissions will take place. And methods like limit and takeWhile are why a stream works by taking the data from top to bottom, left to right in the stream, rather than left to right, top to bottom. And that way, it'll end just as soon as it needs to end. It won't go any further. There'll be no unnecessary processing at all, which is good. And then there's a whole slew of terminal operations that are also short-circuiting. So we mentioned them before: findFirst, findAny, any match, all match, none match, and so on. And these also typically, not always, but also typically take predicates. And if the predicate returns false, then something will happen to short-circuit things. Now, in some cases, like findFirst, it just finds the first one. There's no predicate required there. Just whatever one happens to get there first is the one that's taken. And in fact, you're using that for your programming assignment number 2 in order to be able to stream things together where you only have one element in the stream. So we just use findFirst to extract that element. So those are short-circuit terminal operations. So always remember that you can have both short-circuit intermediate operations like limit, takeWhile, dropWhile, and so on, and short-circuit terminal operations like findFirst, findAny, and so on and so forth. So important things to remember when you start writing code and you need it to not always run to completion for everything that happens to be in that stream. So that's a quick overview of short-circuit aggregate operations in Java streams. Remember, aggregate operations include both intermediate and terminal operations.